Okay, today we're going to do Unit 7, Notes number 10, which is scale changes. So this will be our last notes for our Unit 7. We will be taking our test here in the at the beginning of next week. So with scale changes, we're going to have to write the equation for a graph, and then we're going to apply the scale change. And that'll make more sense when we get through the first example. So the first thing we want to do, it says that this picture is the graph of f of x. So we have to write the equation for this graph. So we got to find our 2 points. So we have 0, 1, and 1, 4. So our b value, we're multiplying by 4. So our a is our y-intercept, which is 1. Our b is 4, and then our d has always been 0. Put that into our equation, we get y equals 1 times 4 to the x. So next, we're going to put it into, it says, write the equation for the graph of y equals negative 3 f of x plus 1. So right here is where we're going to put in this part of the equation. So we're just going to plug it in to our new equation. So I'm going to have y equals negative 3. And I'm going to create brackets for my new equation, which is going to be 1 times 4 to the x. Close my brackets because that's where I put it in, and then plus 1. Then the only thing you have to do is if there are 2 numbers right here, you have to distribute them. You don't distribute it to the inside of the parentheses or your b value. So your final answer will be y equals negative 3, 4 to the x, plus 1. That's all we're doing today. Okay, let's go to another example. So it says write the equation for the graph. So let's find our 2 points. 0, 3. And then we're going to have to go and put 0, 3 right here. So we're going to have to go in this direction. So we're going to have to put negative 1, 6 first. Because remember, we want to list our x values in order. I'm going to rewrite this up here, you guys. Okay, so from 6 to 3, you're multiplying by 1/2 because we're going down. So our a value is 3, our b value is 1/2, and our d value is 0. So our equation will be y equals 3 times 1/2 to the x. Okay, so I'm going to take this equation and I'm going to plug it in for f of x. So this is where I'm putting in my equation. So I'm going to have y equals negative 2, do my brackets, 3 times 1/2 to the x, close my brackets, minus 6. If you remember the first one, you only have to distribute to that first term. So we're going to have y equals negative 6 times 1/2 to the x minus 6, and that is our answer. So if you're comfortable with writing the equation and just plugging in, remember you have to distribute that one number, and you should be good. Okay. Next example, we have to write the equation. So we have 0, 3. And then we're going up to 1, 9. So we're multiplying by 3. So our a value equals 3. Our b value, because our y-intercept's 3. Our b value equals 3 because that's our common ratio, and our d is 0. Write your equation, y equals 3 times 3 to the x. We don't need to put the plus 0. So we're going to take this and plug it in for f of x. So f of x is where we're plugging it in. So we're going to have y equals negative 4, 3 times 3 to the x plus 5. If you remember, we just distribute to that first term. So our final answer is y going to equal negative 12 times 3 to the x, because our b value doesn't change, plus 5. That's going to be our answer. Okay, let me know if you guys have any questions on any of that. We're going to continue on to the back page. And I believe we have one more example. Okay, so this one, since it's going down, it's going to be decay. So remember, your b value will be a fraction. So this would be a 0.04. And then we can also go to the right on this one. So 1, 2 would be the next point. So you're multiplying by 1/2. So our a equals 4, because that's our y-intercept. Our b is our common ratio, which is 1/2. And our d is 0. So we're going to have y equals 4 times 1/2 to the x. And then we're going to take this. We're going to plug it in. So I'm going to have y equals negative 2. Then 4 times 1/2 to the x minus 6. Just distribute to that first term. So you're going to have y equals negative 8 times 1/2 to the x minus 6. And you are finished. Okay, so that is it for the scale changes. So the next two are just going to be review problems. So let us know if you guys have any questions. Describe all the transformations. So what I want to look at is I want to look at my a value, whether it's negative or positive, and whether it's going to be a stretch or compression. Then I'm going to look at my b value, or my d value, sorry. So we have a negative sign here. So this means reflection over the x-axis. Then we can see that our a value is less than 1. So that means it's going to be a vertical compression. By 0.6. If it was bigger than 1, then it would be a vertical stretch. Then lastly, the plus 5 on the end means it's a shift up by 5. Okay, let me know if you guys have any questions on the transformations. Okay, last problem. Our same and different. So what we want to do is we want to plug this into our calculator and sketch our graph. So if we plug it into our calculator, and I'm just going to plug it into my calculator and sketch my graph. Make sure you guys are sketching these, okay? So first of all, we know our b value is the 1/2. That is in our equation. So we have to find our a and our y-intercept. So whenever I graph it, my y-intercept's right at 0, 0. And my horizontal asymptote is at y equals negative 1. And then my graph goes like that. That's not the prettiest graph. Okay, so I have my three things, my b, my y-intercept, and my horizontal asymptote. So this one, our horizontal asymptote is y equals negative 1. Our y-intercept is 0, 0. And then our b value, we have 0, 0. And the next point is 1, 1. We're going to have to go to the next point, which is 2, 3. Because you can't multiply by 1 because then it wouldn't be an exponential function. So it looks like they're multiplying by 3 here. So our b will equal 3. Okay. First, are our y-intercepts the same? Yes, they are both 0, 0. Bases, well, honestly, you could just look at these and realize both your bases are different because one's growth and one's decay. But we also know that one's 1/2 and one is a whole number. Since their bases are different, they have to be a different growth or decay. Domain is always the same. Horizontal asymptote is the same because it's both -1. For horizontal asymptotes are same. If they're above the horizontal asymptote, then their ranges will be the same. Oh, I put those in the wrong column, you guys. Then their ranges have to be the same also. So that would be your answer. Okay, let me know if you guys have any questions on that, and you guys can get started on your homework.